Hi everyone, this is Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we are going to discuss the topic past transistor logic. Here is the outline. Starts from past transistor and its advantages and disadvantages and transmission gate logic and assessment. Okay, we are starting with past transistor logic. First, we want to see what is past transistor logic. It is a logic design style where transistors are used to pass signals directly rather than switching them like in CMOS logic. If you see here in this diagram, NMOS transistor is taken with gate terminal is mentioned as a control signal connected with B variable and A will be the input logic and Y will be the output. So the output Y is logic high when the input A is logic high and the control signal B is logic high. So only when A and B is high, then your output will also be equal to higher value. For all other three input combinations, the output Y will be is 0 or high impedance state. Okay. Coming to the strength of a signal, so if we pass a signal through the NMOS transistor, NMOS is better in passing strong 0 but degraded or weak 1, and similarly PMOS passes strong 1 and degraded or weak 0. Thus NMOS are best for pull down network and PMOS is best for pull up network. Coming to the several examples, transistors can be used as a switches. Shown here, the above diagram shows the NMOS transistor and below one shows the PMOS transistor. We are starting with NMOS transistor. When the control signal G is given as 0, then the circuit will be, that is the transistor will be off and there will be no flow of signal between the S and D. Similarly, if it is equal to 1, if the control signal is equal to 1, then the circuit will be closed and then there will be a flow between the S and D. So in this case, if S equal to 0, then output will be also equal to strong 0, and if S equal to 1, then the output will be equal to the degraded 1. Similarly, coming to the PMOS transistor, when the value G equal to 0, so based on the PMOS structure, the transistor will be switch on and the signal from S will pass towards the D. Then based on the S input, if S equal to 0, output will be 0 and S equal to 1, output will be the strong 1. This is the case for pass transistor. And coming to its advantage and disadvantage, it is simpler to design and reuse of already available signals and low contribution to static power. So these are all some main key advantages of the pass transistor logic. Coming to the disadvantage, NMOS pass transistor is not capable of passing good logic 1 due to threshold voltage effect. Similarly, PMOS pass transistor logic is not capable of passing good logic 0 due to threshold voltage effect and not suitable for cascading circuits. So if more than 3 or 4 transistors are cascaded, then we will obtain the very degraded or weaker output. So we need to move towards the transmission gates for the better output. So because pass transistor produces the degraded output, we are moving towards the transmission gate logic. Here the transmission gates passes both 0 and 1 well. Here we are seeing the symbols of the transmission gates. We are seeing the several symbols. Here we will be having for a single transmission gate, we will be having one PMOS transistor and one NMOS transistor. With this, we are having two control signals and one input signal and one output signal. In any of the signal, if you see here, A will be the original input signal and G and GB will be the control signals, and B will be the output based on the given input. So this is for transmission gates, and which will provide better results when comparing with the pass transistor logic. So with the help of the transmission gates, we are going to design the 2:1 multiplexer. So here the control lines is represented as S variable, and D0 and D1 are the two input variables for the given multiplexer. The output based on the control lines is given as Y. So here we are using two transmission gates in order to represent the 2:1 multiplexer. So here are some assessment questions based on our pass transistor logic and transmission gates. So in this today's session, we have seen the basic introduction about the pass transistor logic and its advantage and disadvantages, and then we moved to the transmission gates and how to design the logic circuit using transmission gates. Okay, thank you. We can see in the next video.